Good morning, students. Today, let us start with a new chapter called as alcohols, phenols, and ethers. So, from this chapter, with respect to board exam, we are going to get 7 marks, where there will be one question for 5 marks and one question for 2 marks. Okay, this is the weightage according to board syllabus. So, when it comes to alcohols, phenols, and ethers, first question arises: why alcohols, phenols, and ethers all three are categorized in a one common chapter? So, when we analyze with this particular question, when I write the functional group for an alcohol, alcohols are given by the functional group OH, and this is generally represented by ROH. When I consider a phenol, phenols are represented by benzene ring, where benzene ring is attached to OH group. This is known as a phenol. And if I write the general formula for an ether, ethers are represented by ROR dash. So when I go through with all these three general representation, all representation contains what? Oxygen as the common entity present in it. Hence, this chapter, alcohols, phenols, and ethers, it can also be called as organic compounds. It can also be called as organic compounds containing oxygen, because oxygen is the common thing that is present in alcohol, phenol, and ether. And ROH, benzene ring with OH along with ROR dash are the general formulas for alcohols, phenols, as well as ethers. So when we go through with the general representation of alcohols, phenols, and ethers, here OH will be the common functional group present in alcohol as well as phenol. The major difference between alcohol and phenol is that in alcohol, R is always an alkyl group. But when we compare with phenol, phenols always contain a benzene ring attached with OH group. So this is the major difference. With respect to these alcohols, alkyl groups will be always linked with the functional group OH. But when it comes to phenols, in phenols, benzene ring is attached to OH group. This is the major difference between an alcohol and a phenol. Majorly, when we start with the classification, next concept, the classification related to alcohols and phenols, this classification majorly depends upon two different categories. The first category is with relevance to number of OH groups. So, based upon the presence of number of OH groups, alcohols and phenols is categorized as monohydric, dihydric, and polyhydric compounds. Means, if one OH group is present, then it is called as a monohydric alcohol or a monohydric phenol. If two OH groups are present, then it is called as dihydric alcohol or dihydric phenol. Polyhydric means if it contains more than two OH groups present, then it is called as polyhydric alcohols or polyhydric phenols. So, based upon the number of OH group present, both alcohols and phenols are categorized into monohydric, dihydric, and polyhydric alcohols as well as phenols. Now, let us write the examples for monohydric alcohol and phenol, dihydric alcohol and phenol, as well as polyhydric alcohol and phenol. So I will make this into two different categories. One with alcohols as the first one, and the second one I write it as phenols. So monohydric alcohols. So I will write the classification as mono, di as well as poly. So when it comes to monohydric alcohols, mono means one OH group will be present, and I'll write an example of CH3OH, which is nothing but methanol, which is a monohydric alcohol. And when it comes to monohydric phenols, I will write a simple example of phenol, where this phenol consists of only one OH group present, which is called as monohydric phenol. Suppose if I write one more example for dihydric alcohol, this is CH2OH, single bond CH2OH. I can call it as ethane, 1, 2, 2 carbons. Root word is ethane. Ethane 1, 2 diol it is, which is nothing but a dihydric alcohol. Suppose if I want to write a phenol which has two OH groups present. So here two OH groups are present. Hence, I can call it as a dihydric phenol because it contains two OH groups, or else I can also call it as 2-hydroxyphenol because at second position there is one more OH. When it comes to polyhydroxy alcohols, I can write an example of CH2OH, CHOH, single bond CH2OH, where this can be named as 1, 2, 3. 3 is the longest chain, which is nothing but propane 1, 2, 3 triol, because 3 is the longest chain. First, second, third, prop is the root word. First carbon has OH, second carbon has OH, third carbon also has OH. Hence, I can call it as propane 1, 2, 3 triol. Suppose if I write an example for trihydric phenol or polyhydric phenol, I can write it as 1 OH at para position, one more OH at para position, and 1 OH at meta position. So when I go through with this, so I can call it as 1, 2. So because the functional group should contain the lowest possible chain, if I write number 1 here, some of the locants will be maximum. If I start numbering from here, this will be para, this will be ortho, this will be meta, again this will be para again. I can write it as 1, 2, 4. This is first position, second position, third position, and fourth position. I can call it as 1, benzene, 1, 2, 4 triol. Or I can also call it as, if I go in this direction, the longest chain or the position to these functional groups will be maximum. Hence, 1, 2, 3 trihydroxy, because 3 OH groups are present. I can also call it as 1, 2, 4 trihydroxy benzene, which can be considered as an polyhydroxyphenol. So this is the first subclassification, which is related to number of OH groups present, which is categorized as monohydric alcohol or phenol, dihydric alcohols or phenols, and polyhydric alcohols or phenols. So after knowing this, the monohydric alcohols means the first type, monohydric, has subclassifications based upon hybridization. Now let us discuss with that. So when it comes to monohydric alcohols, these monohydric alcohols are further classified based upon the hybridization of carbon. Means this monohydric alcohols are further categorized into two different types, which is based upon hybridization. The first type is called as carbon bond between carbon and OH group that possess sp3 hybridization, and the second one is bond between carbon and OH group that possess sp2 hybridization, which can also be represented as carbon sp3 hybridized with OH bond, or else this can also be represented as carbon sp2 hybridized with OH bond. Means monohydric alcohols contains only one OH group present in it. That particular monohydric alcohol is categorized into two types, which is nothing but carbon and OH group containing sp3 hybridization, or the bond between carbon and OH should be sp3 hybridized, and the bond between carbon and OH should be sp2 hybridized. Now, let us discuss the detailed subclassification of compounds related to sp3 hybridization and sp2 hybridization with respect to monohydric alcohols.